So here we have Mr. Fromell swinging a basketball around on the 2.5 meter long rope. He's spinning at 1.4 hertz. At the very bottom of the circle, there is 90 newtons of tension in his rope. And what we're going to do is we're going to try and find the mass of the ball. Now, we don't have the mass, which means we can't just jump to finding FC and FG right away, but let's just work with what we got. So over here we've got the frequency, and here you have the radius. So it's pretty easy to find how fast the ball is going. So if I just use the basic 2 pi RF expression, I can easily calculate that the ball is going about 22 meters per second. So there's just a simple thing I can find. Other than that, I can't really find the individual forces, but I do know there's 90 newtons of tension at the bottom. And of course, when it's at the bottom, that tension, that 90 newtons, is a combination of FC and FG put together. At the bottom, you have to add the forces together. At the top, of course, you subtract, because gravity's helping you out, so you actually have to pull with less. So if I do that, I can work with that type of thing. I can't solve for them individually, so I'm just going to work with the expressions and see if that leads me to something. So I know I've got 90 newtons of tension, and that's going to be a combination of the FC and the FG put together. Now, doing a little check to see what I've got here. M's what I'm looking for. I've got the V, I found that over here. Radius I've got, G I've got. M is the only thing I don't know, which means you can solve for it. So I just got to do a little bit of math and get it out. So I'm going to factor out to the M to isolate it. And I factor out the M. I've got V squared over R plus G. And that's centripetal acceleration, and that's gravitational. So really, it's just a combination of the two accelerations, which is basically ma or Newton's second law. That's all it really is. So if I do this, I can put the V in there for 22 squared divided by the radius, which is over here, add the 9.81 to it, and then I can take that, divide the 90 by it, and I can solve for the M. So M will just be that 90 divided by the total acceleration, which is a combination of those two put together. So if I do that, I can calculate a mass of 0.44 kilograms for the basketball. Okay, so now that I have that, let's find something else. What would the tension at the top be? Okay, so let's find out the tension at the top of the circle, which of course is going to be less than the tension at the bottom of the circle. Now that I have my math, it actually makes things an awful lot easier to find individual forces. So I can find my mg and I can find my mv squared over r. So using the mg, I've got the m.44, 9.1, I've got a force of gravity of about 4.3 newtons at the top. Then for my FC, I've got mv squared over r. Mass I know, v is still 22, so it's going pretty fast, divided by the radius. So if I calculate my FC, we're looking at around 85.2 newtons per FC. So I'm going to put those together and find the tension at the top. So at the top of the circle, the tension is what you're pulling down with to the center of the circle. We need 85 newtons for this thing to actually go around in a circle. Gravity is helping you out at the top by pulling down with 4.3. So you would just need to supply the remaining force. So the tension that you would have to pull with would be the 85.2, take away the 4.3, and give or take, you're probably looking around 81 newtons of tension that would actually be left. Alright, so now that we've done that, let's find something else. What would be the minimum speed required to go around the circle? Well, when you talk about that minimum speed is occurring at the top of the circle, because that's where the circle will fail if this is not going to work out. And of course, at minimum speed, you feel nothing at the top. Gravity is supplying all of the FC. So the FC is entirely supplied by the force of gravity. So mv squared over r is going to be equal to mg. So nice that the masses will actually cancel out, which makes sense because mass has nothing to do with how the effect of gravity on an object. and then we can solve for that v. So the minimum speed we're looking at here would be the root of rg. We've got the radius, we've got the g, and we can find that minimum speed. So if we plug in the 2.5, we plug in the g, multiply them, don't forget to root, we're looking at, well, just around 5 meters per second. So Mr. Flamel, of course, is really strong, so he's easily going way past that minimum speed of 22, but if you slowed it down, you can slow it down to 5 and you'll still be okay.